This is going on 157 when we're done. All right, so hyperbolas, it's our last of the conic sections that we're going to talk about, and that's what goes in this blank right here. A hyperbola is the locus of points in a plane such that, and I left a blank here this time, which I hadn't on the others, because for an ellipse, if you remember, ellipse to show you. Well, on an ellipse, every point on the ellipse is the same. The sum of the distances from that point to the foci is consistent for every single point, right? And that's when you add the two distances. Well, what happens for a hyperbola is that it is the difference of the distances from 2 points called the foci. And that is a constant. Okay, so instead of the sums being constant, it's the difference that's constant. And that is what gives us our hyperbola. So our standard form equations, whether we either have a horizontal transverse axis or a vertical one, we know for both of them, it's some fraction and then minus some fraction equals 1. So some fraction minus some fraction equals 1. So we changed from plus to minus from an ellipse, because in an ellipse it looks the same except it's the addition of the two, and here it's the subtraction. And remember also on here, instead of a always being the biggest number, a does not have to be the biggest number. A is just the first one. So it's a squared and b squared in the denominators, and it's always in that order for hyperbolas. If it is a horizontal transverse axis, like the x-axis is, then your x minus h term comes first, then your y minus k term comes second. If it's a vertical transverse axis, okay, and that's the one where the vertices and the foci and everything all line up, then like the y-axis is, then the y term comes first. And order here totally matters because it's a subtraction. Okay, everybody good with that? Then we're going to label some things on these pictures, but not everything, because we already have everything labeled, but I just want to talk back through some of it. So we know that this point here is the center, which is HK. Then this here, since we're opening horizontally, this is my two foci. These points, which I could not get them on there very well, and I know it's kind of small I'm going to put a little arrow for the vertex, because it doesn't really fit in there. I'm not going to put C for the center because I don't want it to confuse you with the other C. Obviously, hopefully you understand that that's the center and we have it labeled up here. There are 2 points here that we actually are interested in. They don't really go on the curve itself, but what are these things called? The co-vertex or the co-vertices. Yes, good. So then, just like on the other ones, the distance from the center to the vertex, that length right there is A. The distance from the center to the co-vertex is B. In an ellipse, A is always bigger. In a hyperbola, it is not. All right, not necessarily. And then the distance from the center to the focus points, that length is C. Everybody good with all that? So then over here, let's label a couple of things that aren't necessarily the same things. We'll put our HK here, because the arrow was already there. And from vertex to vertex, this line segment right here is one of the axes. So this is the transverse axis. Oh, goodness, I'm leaning with my ID. Okay, so the transverse axis is not always you can't tell which one I did. Not always the vertical axis, but it is the one where the center and the vertices all line up. And then this one right here, going from the two co-vertices, that is the conjugate axis. And then these two lines that we use that we haven't had on the other ones, what are these things called? The asymptotes. Or asymptotes, as Miss Rice and Miss Archer both say, but that's not how it is spelled. I don't think that's right. I think it's just one of those things that's a little weird. Asymptotes. Schoolology, I know that drives me crazy. One time in my department, I was finally like, okay, we're all going to practice because it's not schoolology and it's driving me crazy. Like, would you look at how it's spelled, please? I'm not going to lie. When the very first time I used it years ago, that's how I was trying to type it in. I was like, why can't I find it? Oh, no wonder, because everybody's saying it wrong. That's why I don't know how to spell it. All right. So another just quick review of this stuff to think through it, and I want you to be able to look at the pictures that are up there. Our center is at HK for both of them. Okay. The other things that are consistent with both forms is the length of the transverse axis. It's always 2a. The length of the conjugate axis is always 2b. Length of the focal chord is 2b squared over a, just like it was for an ellipse as well. And then the other things differ because of the orientation of the graph. So our vertices, this is a horizontal conjugate axis, so it's the x values that are changing, and the distance from the center to the vertex is a, so it is h plus or minus a. The co-vertices, since this is a horizontal transverse axis, the vertical changes, so your h remains the same, and it's k plus or minus b. Remember the foci and the vertices in the center, these things all line up. Okay, so since my x value is changing here, the x value changes for the focus point as well. It's plus or minus c, comma k. Then for your asymptote, this is y minus k equals, I'm going to leave some space and do my second parentheses over here. They both start like that. Right. So then I need my slope. Well, my slope is pretty simple to figure out because it is just rise over run. Right? So for these asymptotes, if I know that I'm going to use this point because that's the center, then my slope is just my rise, which is b, and my run is a. So it is just plus or minus b over a. No, just for this first one. But also, here's what I want you to notice. Rise over run is always the change in y over the change in x. That's what slope is. You've known that forever. So when we do b over a, it's y over x. So here, y over x is actually a over b. Or my rise is my a and my run is my b. So these look very similar to each other. The only difference is the slopes are reciprocals of each other. But again, if you get mixed up on which is which, just look at your graph and think about what's happening. You can get that figured out. Okay? Vertices. This is going to be h and then k plus or minus a. And then h plus or minus b, comma k for the co-vertices. And h, k plus or minus c for the foci. Understanding the concept of it can get you these ordered pairs really quickly, more so than you memorizing all of this stuff, but you understanding how it works is important there. Okay, we good? All right, let's go look at how we're going to use these. All right, so yesterday I gave you equations and we just went and found the stuff and graphed it. Today we have to write the equation and find all the missing stuff and graph. Okay, so let's go ahead and look at what we do have and get that plotted. Our vertices are at -3, -1, and 5. 1, 2, 3, 4, 5, -1. Okay, so here are my vertices. That's already one thing I can fill in. -3, -1, 5, -1. I also have my asymptotes. Y plus 1 equals -3 halves times x minus 1. I'm not going to graph that just yet, just because. Okay, so since I have these things, what I need to help me get everything else is A, B, and C. Just based on what I have right here, can I get any one of those three? A, B, or C? A and B. So what do you think A and B might be? Okay, first of all, are A and B always positive, always negative, or it could be either one? Just in general, because it's a length, right? So A and B are always positive. I know that's a negative slope, but you see how it's plus, oh, well, plus or minus, dang it. There you go, plus or minus. It's always plus or minus the A over B thing. You got to be real careful here, because 3 and 2 are not A and B. That's how we get that slope, but if you have the slope, you can't always just break it up that way. The other thing you have to be careful about, because I started just to give you one vertex, because with one vertex, you can kind of get it right, but you still have to assume something. Even though when we write the equation, we're using the center point here, couldn't I write this equation however I wanted? Like, that's just the easiest way for it. But I could write a different equation and it'd be the same line, right? Like, I could use a different point in the slope and we get the same thing. So you have to be really careful. Like, this might be the center, and if we write it, it is. But if it's given to us, it may not be. And when you put A and B in there, yes, that represents it, but it's really the ratio of A to B or B to A, and those things can be reduced. Does that make sense to you? So we got to be careful not to do that. So what can we find from our vertices right here? What else? Maybe not A, B, or C, but what else could we find if we know where the vertices? The center. Okay. So if I don't have a graph, or my picture's weird or whatever, or if it's a tilted one, we're not going to work with the tilted ones right now, but if I did tilt it, they went like this instead of horizontally or vertically, I know I can find the center by counting right here, but officially it is actually the midpoint of those two, right? And midpoint's easy, you just average the points, okay? On the graph, it's easy to find too. We can just go and eyeball, and count, and that's fine. That's still finding the midpoint, and that's your center. So it does end up being that your center point is 1, -1, but just know it doesn't necessarily have to be. I can even give you the line in a different form. So I know my center point is at 1, -1. So now, this distance right here represents what? A. This is A. And what is A equal? 4. Right? So since this is the ratio, and I know it says a -3 halves, and you can use that, but just know that A and B are always positive. I would just use the positive version of this because this is just one asymptote. So I know that 3 over 2 is supposed to equal, that is B over A, right? And I know what A is, so that is going to be B over 4. So what does B have to equal? 6, right? Because you should be able to really just look at that one, but 3 times 4 divided by 2, B is 6. Okay. So I can go ahead and graph that, and from the center point, I can go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what this gives me is my little rectangle, so that I can graph the lines. I could have graphed them from what I had, but it just makes it a little bit easier to do. We'll go ahead and graph the asymptotes then. Here's my asymptotes. I would suggest you use a straight edge. I can't make mine straight and dotted at the same time on this. Oh, maybe I can. I just don't know how, so I won't worry about it. So there are my asymptotes. Now that I have A and B, what else can I find right now? C. And for a hyperbola, C squared equals A squared plus B squared. So C squared equals 16 plus 36. So C squared equals 52. Can you simplify that square root? It'll be the square root of 52. That's 2 and 26, right? That's 2 and 26, so that becomes 2 and 13. So what is C? 2 square root of 13, which that becomes about 7.2 something for when we need it. All right, so let's see what else we can fill in here. I've already plotted my co-vertices, so I'm thinking I can probably go ahead and figure out what those are. That is just, I'm changing the y value, so it's my center point plus or minus the b, or you can come get it off your graph. You're at 1, 2, 3, 4, 5, 6, right? So we're at 1, 6, and 1, what? Negative 7. So to find the foci, I take the center and I'm changing the x value, right? So the x value is 1. It's going to be 1 plus 2 square root of 13 and 1 minus 2 square root of 13. So when I actually go to graph it, I'm going to go, let's see. What was it, about 7.2? So 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6, 7.2-ish. 7.2-ish. Right about there. These are my focal points. Okay, so some of you, yes. Is it? Oh, I counted from the center. Is that wrong? 1, 2, 3. It is. Damn. I think I counted from the center when I was counting my graph. Thank you. Yes, because if I'd actually looked at what I was doing here and added 6, that would be 5. Thank you. So my focal chord length is 2b squared over a. So that's going to give me 2 times 36 over 4. And if you write it down like that instead of actually doing all the math, it makes it easier, right? Because I can divide that out and get 9. 9 times 2 is 18. Here's one thing that as I was grading stuff, I saw some things happening. My focal chord length is 18. Do I count 18 from the focus? No, I only count 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be a really fat one. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And then same thing over here. Bam. And about there. Also, some of you are grabbing the wrong points. Like when you plot everything, you're not putting the curve on the right points. And it's not happening every single time. So I think it's just a matter of we weren't paying attention to what was what on your graph. So my curve goes from the vertex through that focal chord point, like so. And there's your graph, and we got everything we needed, except what don't we have? The equation, yes. That's something else that some of us were leaving off there. So in order to do this, I know it's fraction minus fraction equals 1. It opens left or right, or left and right. So my x is first, and it's going to be x minus 1 squared, and y plus 1 squared. A squared comes first, so that's 16 over 36. There's my equation. Everybody okay with that? Lots of pieces. A lot more pieces on our hyperbola to focus on than the rest. Any questions? All right, so number 2, vertex is at -3, -2. My vertex. And then my center is at -3, 4. And my focus is at -3, -8. So one vertex is at -3, -2. My center is at -3, -4. One focus is at -3, -8. Okay. So from this, can I figure out A, B, or C? Which ones can I figure out? A. Okay, so I can figure out A. What is A? 2, because it goes from the center to the vertex. A is 2. I can also figure out which one? C, because from the center to the focus point is 1, 2, 3, 4. So I can figure out my other vertex. My other vertex is going to be at -3, what? -6. Right, there's my other vertex right here. And I can figure out my other focal point, right? It's right there. And that's going to be at -3, 0. We got all that so far? If you don't have them labeled, you just have a bunch of points on there that you might accidentally use wrong. So I need B in order to get the rest of the stuff. So I know that C squared equals A squared plus B squared here, because the sign here is opposite of the sign in the equation itself. So that means I get 4 squared equals 2 squared plus B squared. It's going to give me 16 equals 4 plus B squared. So B is the square root of 12, which is 2 square root of 3. Square root of 3 is 1.7 something something. So when I double that, I get 3.4 something something, right? So this is a 3.4 something something something. It's really 3.46, whatever, but that's good enough to estimate on here. So now to find my covertices from C, I can go out 3.4 something something. 1, 2, 3.4 something something. That's a covertex, that's a covertex. What does that help me figure out? The asymptotes in my rectangle, yes. So I can draw my little points here, and I'm going to put the rectangle in this time. And you don't have to all the time, but I want to make sure that you understand what we're getting this rectangle here that happens every time that helps us get our little asymptotes. And I think the rectangles are on some of those pictures that I gave you that were already done. It's not part of my curve, but it gets me what I need. And even though I don't have the asymptotes written yet, I can go ahead and go in and graph them, because they're going to go from the center through the corners of this rectangle, like so. What did I do? Dang it. They're not right? What did I do wrong? 1, 2, 3.4, 1, 2, 3. It wasn't me this time. How exciting. Okay. Like, dang it. I can't count. I can't even count. That's bad. Okay. No, but please stop me if you think I'm wrong, because it would not surprise me at all. All right, so I've got my asymptotes in there. I can go ahead and write the equation for my asymptotes. I know that it's going to be y, I use the center, plus 4 equals plus or minus something, and then x plus 3. So this time, it is rise over run. It is b over a, right? And so b, no, it is a over b. Dang it. It is a over b. So I'm looking for a over b, and that is 2 over 2 square root of 3. Now I can reduce that, and that gives me 1 over the square root of 3. Can I leave it like that? No. So when I rationalize this, what does it become? Square root of 3 over 3. So that's my slope. It's a yucky slope, but it's a slope nonetheless. So my covertices, I can write the equation for. My center x value is -3. And to that, I add 2 square root of 3. And then I also get -3 minus 2 square root of 3, -4. The last thing I need to be able to graph this is my focal chord length. And that is 2b squared over a. So this is really square root of 12. So when I square it, I get 12. So I'm going to get 2 times 12 over 2. And that means that the answer is just 12. So from my focus, I can count, hopefully correctly, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That tells me that my thing isn't really that great here. And then 1, 2, 3, 4, 5, 6. 6. Draw that in, starting from the vertex. And make sure on these, like, okay, I need to redo that one. You see how I did this? I need to fix that because it's not going to come up higher from that asymptote. You need to try, and obviously I'm not going to just totally count it wrong if your graph isn't perfect. But the idea is that it hugs the asymptote because that's what an asymptote is. It gets closer and closer to it. It's just not going to get farther away from it. Something like that. Then to write my equation, something minus something equals 1. Bless you. This is opening, bless you. Up or down, so this is my x plus 3 squared, y plus 4 squared. A squared comes first, which is 4. B squared comes second, which is 12. Everybody okay with that? Dang it! Dang it! I even think I even said, so your x term comes first. No, it opens up and down. I did say that though, right? I didn't say left and right. It opens with a vertical asymptote, yes. A vertical transverse axis, so it is, oh, the whole term is wrong. The whole term, the two terms switched their places. See, Cody, this is why you can't sleep, because then you can't catch my mistakes. All right. So this is y plus 4, and this is also why you don't use pen if I'm teaching, and then x plus 3. Okay, thank you. Again, we're good? Alrighty, so I'm going to give you a second, and what I would suggest on this one is, oh no, you have some room. You didn't have room on the other ones, but you could also use the room up. You have a lot of room up top that I don't really have. But I want you to, I'm going to give you a minute to complete this square on your own because that's one thing that's happening that's not always so perfect for everybody. So you complete the square without me doing it with you. I'll go check roll and give you a second to think through it. And then we'll walk through it, make sure we can all complete the square correctly. Sorry, right out of the ribbon. Yes. Thank you. Thanks. Well, I kept writing. I kept leaving off my variable and leaving off my square. Okay, there you go. That's all. That's my only mistake there. Okay, thank you. Oh, shoot, I did change it there. Okay, so this is what I got once I fixed my mistakes. Yes, and that's what I got over here. You can write this without the 1 on the bottom here if you wanted, and that's okay, and you might see it that way. So it is possible to see an equation for a hyperbola without a denominator, but that would just imply, obviously, that the denominator is 1. Be careful. Make sure that you are factoring these things out before you complete the square, and then after you complete the square, when you decide how to balance your equation, that you actually multiply by whatever the multiplier is. And on the hyperbolas, you got to be careful, because if that's negative, you're actually subtracting 4 from this side, so you have to subtract the 4 from this side. I'm adding the 4 here. I didn't have anything to multiply it by right here, and then this 4 came from over there. Okay, we all good on that? Completing the square, we can handle that? Okay, good. So then we can find all this mess pretty quickly. Since this is very similar to what we did yesterday, let's go ahead and do number 4 so I'm not rushing through it. I think you can handle that. I went ahead and put the graphs on all of them, not knowing if I'd have time or not. But all right, so our vertices here are at negative 4, 4. That's 3. Dang it. Negative 4, 4. That's a vertex. Negative 4, 2 is another vertex. Focus is at negative 4, 0. So negative 4, 4, negative 4, 2, focus, negative 4, 0. So from this information, can I find my center pretty easily? Yeah, the sooner you can find the center, the better. So here's the center. It's going to be at negative 4, 3. Which means, what is A? 1. What is C? 3. Okay. So then I know that C squared is equal to A squared plus B squared. So 9 equals 1 plus B squared. So B is the square root of 8, which is 2 square root of 2. So square root of 2 is about 1.4-ish. And then, so it's going to be about 2.8-ish. So 1, 2.8-ish. 1, 2. So I can get my little rectangle here. And go ahead and draw in this here. I can also go ahead and get my other focal point, right? Because that's just going to be negative 4 what? Where's my other focal point? Go from the center and I count 1, 2, 3. So that's 6, right? That's my other focal point. My co-vertices I already found, so that is going to be negative 4 plus 2 square root of 2 and negative 4 minus 2 square root of 2. My focal chord length is 2b squared over a. So that's 2 times 8 over 1. That is 16. So from my focus point, I count 1, 2, 3, 4, 5, 6. Ugh, my lines must be really bad. Okay, I was like, they're either really bad or I did something wrong. I think my lines are just curvy is the problem. And the other issue is that we're kind of estimating our 2.8-ish, you know? And so I think I'm going to erase these, and then I'm going to draw that in. Especially since I don't even have a straight edge. If I had a straight edge, I think it would be a whole lot better. Let me go ahead and get my, so 1, 2, 3, 4, 5, 6, 7, 8. Either that or I'm totally wrong, but I don't think I'm totally wrong. Did we do something wrong? Is yours like way off? It is the square root of 8, right? Okay, I'm just making sure. I'm like, I've got the right numbers here. I did all that correctly. C is 3, right? I think so too. I think that it's just a matter of, okay, just double checking that. 2, 3, 4, 5, 6. Because clearly I don't trust myself, and I know y'all don't trust me either. So, and that's okay. But I think you're right. It's because it's so wide that the asymptote is so close. If I trusted myself better, and probably my estimation of my points is a little bit off, but I think that that's what's happening here. It's definitely. Oh yeah, once I draw that in a little bit better. Because our asymptotes are correct. 1, 2, 3, 4, 5, 6, 7. Oh, let's see. Out here. And especially because it goes off the paper. Oh, I'm not even drawing it from the right line. And then there. Okay, so our asymptotes are going to be at y minus 3 equals plus or minus. And is this going to be a over b or b over a? A over b. So it's 1 over 2 square root of 2. So when I rationalize, it's going to give me the square root of 2 over what? 4. Square root of 2 over 4, and this is x plus 4. So to write my equation, this has a vertical transverse axis, which means the y term comes first. This is y minus 3. I think I said it and did it right this time. And this is x plus 4 squared. A squared always comes first, so this is 1. B squared comes second, and that is 8. And there is your equation. Okay. Any questions at all? All right, so I've given you some stuff back. On the circle one, when I was grading that, I went, oh my God, I don't know why I made this so long, for y'all even. And I thought, there's no way I can get it all graded. So I did not grade all of it. I will put in Schoology the key to the whole thing and tell you which ones I actually graded, because off the top of my head, I don't think I could tell you which ones I actually graded. But that way you can go double check yourself on the rest of them, especially if you missed any stuff. I only gave you back circles and parabolas because I'm still working on the others. I know there's only 15 of y'all, but I'm telling y'all I can't get anything done. So tomorrow your quiz is only going to be over circles and parabolas because that's all I've given you back. I will give you the rest back tomorrow, and then you'll have a quiz over the rest on Monday before your test. And on Monday we'll do the quiz and we'll grade it so you can have feedback right then before your test. Okay? I really don't. I know that there's a lot of stuff I have not given back to y'all in a timely fashion this year, but I don't like quizzing you and testing you if you haven't even gotten any feedback on your stuff. So please take the time to look over what has been graded, and if you did miss anything, at what you missed. Most of it is careless errors or things that I think when you look at it, you're like, oh, duh, I know how to do that. But if there's something, there's a couple of things that keep happening that want to make sure aren't something that you're just totally not comprehending. Okay? So come with questions tomorrow if you have it. Are we good?